last lecture we stopped at circular motion in a polar coordinate. So just to recap, for circular curvilinear motion, we have a curve, and we always measure it from a center, and this is R, and we will have two axes when the object moving from one location to moving towards a location, or there's a direction. So when particles move in the curvilinear motion, you can present it in two axes. One is tangent, one is normal. Okay. Then the velocity always tangent to the center of the curve. And acceleration always, if you have a centrifugal acceleration, then you will point inside. So previously, we arrived at the equation they see on the screen, that V, you have, so previously we have P and N. Now if you're in a polar coordinate, when you're in a polar coordinate, then you are speaking in R and theta. Okay. So you are using the same diagram here. You just convert your curve into radial and theta. So as what you see on the screen, your V, you have two direction, where it is R dot UR plus R UR dot. Okay. Okay. Then we arrive at one equation. We derive the equation. At the end, we arrive at this one. V in VR, UR plus U theta. So your VR will be R dot. R dot means the R dt. Theta is another one, R bracket theta dot U theta. Okay, this means this one, theta dot means the theta dt. Okay. Okay. Now we do the same for acceleration. Right, we do the same for acceleration. So previously, because it's a vector, you can square the VR, square the V theta. It's the same here. This is V theta, this is VR. So you square it, you square root, you still get back the resultant. Okay. Then from there, you form a vector diagram. You know the theta from the VR or V theta. It depends on how you draw on your free body diagram. Okay. You do the same for acceleration. So this one, I won't go deep into the derivation. It's more on the application, right? So this one you read from the slides. Basically, it's the same procedure. You know that A definition is dv dt, right? A equal to dv dt. So basically, you recycle the V definition in R and theta direction, which is you see on the screen here. Meaning you do differentiation, time differentiation for this one, and time differentiation on this one. Okay, then you use chain rules and so on. So it's a very lengthy equation. So at the end, you arrive at this lengthy equation, right? Lengthy equation. I go this one very fast. You can read from the slides. right? At the end, you arrive at one equation. But this one I won't ask you in the exam lah. So just at the end, you arrive at this equation. This is important. When you talk about acceleration, A equal to A R U R plus A theta U theta. Now don't confuse with the UR and U theta. It just tell you the direction. It just tell you the direction. It's like when you analyze Y equal, not Y, a location, let's say previously you have your three axes there, X, Y, and Z. So you have X is I, Y is J, Z is K. It's the same. This one is in the R and theta direction. So you can see it as a I, J, or K vector identity, right? Important is you know how to calculate the AR and A theta. So from the screen here, the A theta is a quite lengthy calculation, but you just memorize the equation. So R double dot means double differentiation. You will be given R equal to, let's say 3x or something like 3 something. You'll be given an equation. Later we see in the tutorial question. So let's say R, you're given equation 3x plus 3y square something. Then you differentiate, then you double differentiate, and so on. So from the screen there, the blue color, you need to do the first thing, R and theta double dot, single dot, square, right? Then you get the first component for the radial direction. So the first one, R double dot, means you double differentiate the R equation, then minus R, you copy the equation, and this is a theta dot. Theta dot means you have a theta equation, you differentiate it one time, and then you square the equation, right? Plus R theta double dot plus 2R dot theta dot UR. So when you do the curvilinear motion in radial direction, on your calculation on the answer, you will see R equals something, theta equals something. The next step is you look at the question. The next step you do on your side calculation. You do R dot, which is dr dt. Then you do another one, dr square dt square, means you differentiate this one more time. Then same, you do the same. Theta dot equal what? Theta double dot equal what? Means you double differentiate. So for radial and theta question, this will be the first step you do in your calculation, right? So once you see the question asks you in R and theta, the first step is that you calculate the R dot, R double dot, theta double dot. Then you write the equation that you see on the screen here for V, because V also using dot, R dot, right? So you write this equation, V equal to R component, theta component. Then you write A equation, this lengthy one. You memorize this one and this one. So there are 4 equations to memorize for R and theta question. So this one. So again, the derivation for the one that you see on the screen here, you go home and read from the PowerPoint slides. Again, in exam, I won't ask you how to derive the equation, but how you apply the equation. Okay. Okay. Then again, you go back to the drawing board or your free body diagram. You draw once you find the blue color, like we'll see on the screen here, AR equal to this component, you'll find the value of this one. So when you substitute the value inside there, you'll get the AR value. So what you do, you go back to the free body diagram. You split into 2 axes. One is R direction, which is from the reference point, you draw the axis along the R, you draw the line, and then you write AR value here, or AR equals something. Then you split into 90 degree, then you will go to theta. So this is 90 degree, right? 90 degree. So you are forming a vector diagram, the red color here. You're forming a vector diagram. So 90 degree, then you can move here, then you draw a resultant. You draw resultant, then the same magnitude is square this one plus square this one square root, and you are still using trigonometry, tangent or tangent. If sometimes you can use sine or cos, depends, but most of the time it's tangent. So tangent theta equal to this one, then you inverse the value. Okay. So this is just an elaboration on what you get from the equation here. Huh? Right. Now this is just a remind. Acceleration, it will not be same as the velocity. As acceleration will not be tangent to the path, so it will follow along the other r theta axis or tangent normal direction. It depends on the question whether you put it in r and theta. Okay. Now you might ask, what is the difference between r theta and theta tangent? You see the whiteboard here? When you draw theta tangent and you draw the r theta diagram, do you see the difference? Can you spot the difference? The tangent theta condition and the one that you see on the screen, polar coordinates. What is the difference? Where is your reference point, or where is your object refer to what? Okay, tangent theta, you focus on the object. Tangent theta means you focus on the object, referring to the curve. You point to the center of the curve and the tangent of the curve. This one focus, tangent theta focus on the object. But the polar radial, polar coordinates, you focus on other object or other location. You're referring to somewhere outside the vehicle or things. So don't use this one combine with the tangent normal. Radial and theta is from a reference position. Means you look at outside one. Okay, understand? So don't confuse the r and theta equation. Okay. So you can do the same if you have a three-dimensional. So all the while you see on the screen here is all 2D, two-dimensional. But if you have 3D, you can write in them in the 3D direction. So if 3D, you have a Z direction already. So your equation will become the one you see on the screen here. We will not go into three-dimensional, but just for info, there is a way to do the same. Because previously what we derived in the lecture is that RUR. Previously we do this one, but now you have one more component with the Z direction. You do the same for for the derivation, differentiation. You differentiate this one, you get this one you see on the screen here. I just summarize for you. Okay. And then acceleration also the same, but it will be longer. So I won't ask you in a three-dimensional question. It's way too complex. And we have a lot of chapter to ask you. So I won't ask you in this case in three-dimensional. Okay. Let's look at example of what we learned so far. So same, you look at the question. If you read the question, you know this one is straight away is a polar coordinate question. The polar coordinate question means you are referring to some place and not to the object. Don't confuse with the tangent and normal question. So once you see theta dot, it means you're referring to another location outside the curve, right? Or some location. So in the amusement park, you have a chair, right? And this chair is rotating in a circular motion, right? In the radius of r, the arm OB has an angular velocity so and so, and angular acceleration so and so. Okay, you have a R and referring to one location. Determine the radial and transverse components of the velocity and acceleration of the passengers. Ignore the size in this calculation, means there is no mass involved in here. So if you see the question, ignore size, means it tell you that ignore mass. When you ignore mass, don't confuse with later chapter. So later chapter, we will learn about Newton law, F equal to ma. So if you see this one, ignore size one, normally is chapter 1 question. It asks you about the velocity and acceleration only. So don't go and add more information there. All right. Now you have a theta and this chair moving in the clockwise direction, right? So you're given the two information, theta, theta dot, theta double dot. So you want to find the radial and transverse component. So I just copy the diagram. So first steps, draw free body diagram, and then know what you are trying to solve. Coordinate system. In this one, previously, what we do for a coordinate system, we draw x and y, tangent, normal direction. Now, you see the question give you theta dot, theta double dot is a polar coordinate question. So you go back to the free body diagram, you draw where is your R. R is from the reference point, in this case, at the center of the circle, and positive as you move up, move outside is a radius position, positive going out. And the theta means in this case, we are following the chair. We're following the chair, the direction. There is a direction and a clockwise. So this is the theta that you are referring to. Right. Now, in this case, you see the question didn't give you any a constant number. So basically, it expects you to derive equation. So if you see question that have no numbers or no value or no constant value inside there, expecting that we are asking you to derive equation. Okay, so once we have the thing, so you go back to the chair, right? So this kind of question, normally when you draw the axis already, you can take the object out. Take the object out and then maintain the coordinate system. So in this case, you know that this one move in a circular and radial like this one, and theta positive to the here. Anyway, because the angle here is positive because it's moved in this direction. So positive in this direction. Okay. So it's the same. In this case, you put inside tangent and normal axis there, right? It's a combine of two, right? Combine of two. Tangent means you focus on the object. Normal also you focus on the object. So the theta and R is from the reference location. Reference location. So you combine the two things. So once you have there, then you derive. You derive. Since in this case, the chair was always in the same location or same radius. So what you do, your R is constant. In this case, R is constant. So R constant, like what I propose just now, when you see radius and when you see R and theta or polar coordinate question, the first calculation, after you draw the free body diagram, you draw the axis coordinate, the next calculation that appeared in your your answer is that you write what is R, what is theta, then do this four differentiation. You write R is what, then do two differentiation. R dot, R double dot. Then you write what is theta, do theta dot, theta double dot. Once you do this one, you put inside the two equation here. R equal what, V equal what. That is the normal procedure for polar coordinate question. Okay, so this is the constant value. You differentiate it, you get 0. 0, you time differentiate one more time, what you get? R double dot is what? 0 also. So the next one, you do theta, right? So, and the velocity, I put in velocity there. You know, velocity always tangent to the curve, right? And it's along the curve. And A theta also along the theta, that this one. So the green color is to the T. A theta is to the theta. So there's an overlap of two arrows here. And you know that your acceleration is pointing inside because the chair is always keep to the position. So your acceleration in this way is minus AR. Why minus AR? And not positive. Why? Why? Huh? Why? Where is your positive R direction? Going out. The chair is not going out. So it's pointing inside AR. So it's negative AR. So be careful on the positive negative sign because you're dealing with vector. You're dealing with vector now. Now recall just now this equation. So they are four equation, or you can simplify it into two equation only for polar coordinate. One is V equation and then one is A equation. This one you need to memorize now. So V equal to R dot UR. Again, UR is just a vector unit, right? Plus R bracket theta dot UR. Okay. And A equation here. Memorize, A equal to this equation that was here on the screen. So these are the four equations that is important for polar coordinate. The derivation step, you go back to the PowerPoint slides, right? I won't ask you on the derivation, but we will assess you on the application of these four equations. Basically, it's two equations, right? It's V equal what? A equal what? Right? So if you able to write this one, we also have marks for you. Can be 1 marks to 2 marks for V and A. Depends on the complexity of the question. All right. Now, you know that the first one, you substitute your R dot is what? 0. So straight away, you go to your equation, cancel this one, right? Then you go, then A also you can cancel this one. This one cancel. This one cancel. This one 0, 0. So this one arrive at R theta. Your V equal to R theta. Okay, V. I put the V. V is the magnitude. The magnitude. This one is the magnitude. The magnitude is R theta, which is this one. R multiplied by theta dot. You apply the same for A. You know that R double dot is 0. R dot is 0. Oops. So the first component is negative R theta dot square. And the second part is R theta equal to R theta double dot. So don't confuse between R and R theta because they are two different directions. Or you don't need to write the yellow color one. You just simplify this equation. You can write A equal to minus R theta square UR plus R theta double dot U theta. Also get the correct answer. Okay. Now, example 13 is a equation derivation. You will apply the same procedure. Only different in the test or final exam is you'll be given the equation for R and theta. You do the derivation and then you substitute value over here. Okay, let's look at another example. Okay, a similar question come out in one of the final exam question and also test question. Okay. So this one, you have an object of this one. Rod theta A rotates in the horizontal plane such as theta equal to t cube radian, right? Okay, before I forget, do go and check your student handbook. There's a maximum number you can fail a certain subject. Or retake the certain subject. Okay, Let's continue. So you have this object, rod OA, which is this one, OA, rotates in the horizontal plane such that theta, you are given a certain equation. Theta equal to what? Radian. Our polar coordinate, we always deal with angle in radian coordinates. So sometimes we will change the, we will give you the angle in degree value. So 360 degree equal to 2 pi radian. So you have to do conversion if you're given the degree angle. In sometimes the collar B, in the same time, collar B sliding outwards. As you swing this one because of momentum or initial. So when you swing this one, this ring will move outside. Towards OA, along OA, that R equal to one equation. Means this R, the ring is moving from O to A in a certain behavior, but this one is a linear equation. It moves in a linear, not linear, but this one is, I give you a quadratic equation. Okay. Why quadratic equation? If you view from the top, and you have a slow, high-speed camera, when you swing this arm, when you look from below, this B actually doing a curve motion. If you plot the location from start point to end point, or the T1, T2, T3, T4, you will see the ring is moving in a curvilinear motion. If in both cases, in second, determine the velocity and acceleration of the collar when t equal to 1 second. It means you apply the same procedure as in example 13. Now you're given the equation. What you need to do is a differentiation. Same. You look at the object, identify your coordinate. Where is the r? Where is your theta? This is your r, positive. This is the theta direction. It gives you the both line. So it already gives you the positive direction. There's an arrowhead here. Positive direction is over here, or logically you can think also how this collar move outside. It must be swing from here to there. It must be swing to a certain direction so that this red ring here can behave in a certain way. So sometimes you need to think a little bit. Okay. Then after you put in the coordinate system, what you do? Again, repeat the same. Right, what is your r? What is your theta? Do this differentiation. Differentiate your r one time, differentiate your r double two times. Do the same for theta. Theta, differentiate one time, differentiate two times. Then after you write this one, straight away, go and memorize this. What is your r? What is your a? What is your v? Substitute the value of your differentiation over here inside the equation. Then you get the answer. Okay. Then go to the free body diagram, draw the vector. Draw your vector. Then find the resultant or find the angle. The procedure always repeating like that in that pattern. So no matter how the question come out, you follow the procedure, you should able to get the. Okay, again, first you go to the question, look at the question, straight away draw where is your r-axis positive, where is your theta positive. After that, you write r equal what, theta what, then do differentiation. You should get 4 equation or four constant value here. Normally it's an equation, 4 equation. Then you go to r dot. Before you go here, if the question give you time like that, substitute your t here. Means after you get one equation, substitute t equal 1, substitute inside here. Then you write what is your v. Your v equal to this equation. Go to the answer there, substitute here, substitute here. A also same, substitute, then you rearrange. Then after that, you have 2 direction. V, you have r direction, theta, you have 2 direction. It's a vector. So go to the diagram, draw where is your r vector, where is your v vector, v theta vector. So basically they are 90 degree. Basically, you can build a vector diagram, or you can straight away find the resultant. Square this one, plus square this one, square root, you get the resultant. And you know that they are tangent. Or go to your diagram there, draw a tangent diagram. Draw a tangent triangular. For example, I do that one. So you will get this diagram. This is r, this is theta. So basically, it depends on where you refer to lah. Okay, I'll show you the steps. But basically that. So coordinate system, you draw the rod axis. Okay. So there's r and theta. In this case, your theta is over there, right? Going up there. Yeah. So theta is going here because it swing clockwise like that. Right. Follow the motion, positive, and then r along the rod. Then you know that your VR is along the positive r axis. Your theta is along this way. So we have VR, V theta. This is a vector with its 90 degree. You should be able to find the angle if the question asks you angle. Right, so you have the resultant. Resultant is square this one, square this one, square root. Okay. Okay. So, okay. Now, the question sometimes they have a hidden meaning. For example, this example 14. Your theta is calculating from here. Means the theta dot that you calculate, theta dot at theta double dot, actually calculating from here and not here. Okay, you have to be firm on your direction. So this one is from the question. The question referring to this line. Theta, I already mentioned, theta is from here and not from the object. Again, r and theta is you referring to a reference point. Don't confuse with tangent and normal. Tangent normal is referring to the object. So when you're solving r and theta question, you are referring to the reference point and not object. So this one, the theta is over here. And then this one is an additional or a new theta, which is the gamma here or the delta here. It's just a reference from here, right? So basically, if you understand this diagram, you repeat the procedure for the like example 13. Okay, so you do the derivation. So this one I will do very fast. So r 100 t square mm, you do differentiation one time, you get, right? So this one is just substitute just substitute to get what is the r at 1 second and so on. Okay, then you do r dot. Okay, you should already understand how to get 200t from 100t square differentiation. Okay, then you substitute what is the r dot value in 1 second. Take note on the unit. R is in this case is in mm. So when you differentiate, it become mm over second. R dot means time differential. So put in the unit. Again, if you forget to put in the unit, automatic discount 50%. If this one 2 marks, you only get 1 mark. If you have if this is 1 mark, then you only get 0.5. Normally, I will omit the 0.5. Basically, you don't get marks if the answer is 1 mark. So I won't give you 0.5, 0.5 in the exam. You either get full number or get 0. So you do the same. You get R, you differentiate R dot, R double dot, right? So I won't go deep. I won't explain like how to get from 200t become 200. This one, if you still cannot do, go and ask your mathematics lecturer already. Okay. So again, you double dot already. You actually double differentiation. So your unit become mm over second square. It become acceleration already. Okay. So it means that this one is velocity, but in radial velocity, this one is radial acceleration. Okay. Now, once you have all the value there, what you do the same for theta. So you substitute lah, second, 1 second, how many, and so on. So you are the value you get here is in radian. Okay, in radian. This one, I just highlight that you can convert radian to theta. Why this one? Why I mentioned this one? Because sometimes the question will ask you, where is the position of that object at 1 second? We are expecting your answer in degree and not radian. Radian is for your calculation for R and theta equation. Yeah. So don't come into me, hey sir, I write radian already. Why I don't get marks? It depends on how question asks you. If the question asks you position, please convert into degree. So if the question asks you velocity or acceleration in radial, then you need to answer in radian. Okay. So again, you have angular velocity, which is radian per second, and you have angular acceleration, which is radian over second square. Take note on the unit. Now, once you have this 6 value, right, you pull out the two equation. So it will take some time to familiar, or the equation will come into your mind. So basically, the step is the same. Once you get the answer, you substitute inside the two general equation. Right? You substitute lah. You get your VR is what, V theta is what, and so on. Okay. Okay. And okay, then you get your V, you get one equation. One equation. Don't over jump the thing. This is a vector, so you have radial direction and theta direction. Unless the question asks you what is the magnitude of the velocity. What is the speed? I ask you, what is the speed? Speed means it asks you the magnitude. Try to differentiate velocity and speed. If the question asks you speed, means it asks you the magnitude. So you need to square this one, plus square this one, square root, you get the answer. It will ask you direction. Direction, you draw from the free body diagram. Okay, so you do the square, you get 300 something. The theta, you draw from the diagram. I show you here. What is the delta here? How to get tangent? Tangent, the opposite divided by side. Then you flip the tangent sign. You'll get 56.3. Okay. Okay, this is how you get it. Okay. So the total angle, the differences is that it will be a bit tricky. The total angle you should get theta plus gamma, referring to the original location here. Okay. So what is the theta? What is the theta here? 90 degree is theta is 57.3 just now. Just now you substitute one radian, you get 1 radian. So 1 radian equal to how many degree? So it's here 57.3 plus 56.3. You get 114. Okay, makes sense, huh? Any question? Try to understand the steps. Actually, the step is keep repeating and repeating and repeating. Don't confuse the differentiation. If you're weak in differentiation, don't mix with try to understand the procedure, the general procedure first. Once you understand, then you go and polish up your weak point, or if you're weak in differentiation, then you go and do exercise on that. Okay. Once you have that velocity, you do the same for acceleration, right? So you change the diagram, or you can overlap the diagram with different colors of pens, right? So you put in the R and theta. In this case, the R is pointing inside. Okay. So you substitute the value. So this one you memorize, then you copy the value over here, substitute here, you get the final answer, which is minus something and minus something. So before you draw the arrow, you do the calculation first. So in here, the calculation you get minus. The calculation get minus, then only you draw the diagram, like the red color you see here. Right? So previously, before I show you this calculation, I draw the red color. You might be confused, right? Why is modding in? So the procedure is that you recommend that you do the analysis first. You substitute the value, then you either positive or negative. Then you look at your answer. If it's negative, means you go to the diagram. Like for example, minus 70. Minus means opposite from the axis. This one R positive going out, but you get negative means it's pointing inside. So go to your diagram, pointing inside. So it's here. Okay. Wrong notation here. Yeah. Okay. Correct. Right. So this is R identity. This is theta identity. So then 800 positive. So going pointing this way. So build the vector diagram. You know the theta. So it depends on where you calculate. And in this case, your theta is here, your gamma is here, or phi is here. And you're always referring to the reference point. Don't stop here. Always go back to the question. Where is your original location? Because you are solving R and theta question or polar coordinate question. You're referring to a certain location and not object. So location in this case, your theta plus the angle over here. Right? Okay. So you get someone, this is just for your reference, right? The magnitude is the reference, the resultant is 1/9 something. Then the small angle, the small changes of angle is 68.7. Again, this is on the object, but again, you are looking at a certain, you're referring to a reference point which is outside the object. So you go back to the theta, the total angle is theta plus the phi or gamma here. So you get 169. You know that theta earlier is this one, 57.3. Then plus this one, you get 169. Okay. Okay, what is the application in the real case? Why you need to study or need to understand the R polar coordinate, the tangent, normal direction? Because we are now living in the advanced era with all the high-tech technologies. We are filled up with all the sensors nowadays. So what we use every day, you are actually using all this equation. Um, I'll give you a very extreme example is that sometimes this one is for example this example with the R and theta. Sometimes when you for example player nowadays they use a machine to train. So nowadays you can use machine to predict where to shoot or where to hit. For example, baseball player, basketball player. You can design a robot to catch the object, and then feedback the ball back to the user. So this is one of the equation you use in the robotics movement. You track the object, Then you do manipulation on the motors or hands. Then you give feedback output. It's based on all these calculations because it's keep changing, right? So it's just things. So like I think a few more years, you have more and more consumer products out there that make you very convenient, right? So on. Okay. So we have a 10 minutes breaks. We continue 9 o'clock. We are learn new things already, yeah. Sign your attendance,